We're now going to look at the addition law and mutually exclusive events. So first of all, the addition law. So for two events A and B, A or B, the probability of A or B, so remember the union symbol, the U means or, equals the probability of A plus the probability of B minus the probability of A and B. Now, and is the N symbol, which also means intersection. And then if A and B are mutually exclusive, which can sometimes also be called disjoint sets, then the probability of A and B equals 0. So mutually exclusive is when it is not possible for them both to happen at the same time. So it's not possible to have the intersection of these two events. And if we have that, then the probability of A or B equals the probability of A plus the probability of B. So this first example, if the probability of A equals 0.6, A or B equals 0.7, and A and B equals 0.3, find the probability of B. So we're going to use the addition law, the first equation there. So we've got, I'll just write that out. So probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. So what we know, that A or B is 0.7 equals the probability of A, which is 0.6, plus the probability of B, which is what we're trying to find, minus the probability of A and B, which is 0.3. And then from there, we can just rearrange and simplify. And we will end up with that the 0.4 equals the probability of B. Now, example 2, we've got a class of 30 students and they were given a history test. 7 students scored an A, 11 students scored a B. Then we're going to select a student at random, and A is the event that they got an A, B is the event that they got a B. And the first part is, are A and B mutually exclusive? And what we need to ask ourselves, can the probability of A and B both happen together? Can you have an A and B? Now in this situation, no you can't. You can't on a test get an A and also get a B, so therefore they are mutually exclusive. And we just write a sentence to that effect. So yes, as it is impossible to get an A and a B on a test. Okay, part B, the first thing we want to find is the probability of A, so the probability of getting an A. Now there's 7 students that got an A out of 30 in total, so that's just going to be 7 out of 30. Part 2, the probability of B, which is the probability of students getting a B, which is 11 students got a B out of the 30. Now the third one, the probability of A and B, which will be 0 because it is impossible to have the intersection between them, which is why we said it was mutually exclusive. And then the last one, the probability of A or B. Now because they are mutually exclusive, the probability of A or B is the probability of A plus the probability of B, which is 7 over 30 plus 11 over 30, which gives us 18 over 30. And if we wish, we can simplify that down. And that will simplify down to 3 over 5. And then independent events. So two events are independent if the occurrence of each event does not affect the other. And if they are independent, then the probability of A and B equals the probability of A times the probability of B. So in this example, we've got a coin is tossed and a die is rolled simultaneously. Now, tossing the coin doesn't have an effect on what outcome the dice will have when we roll it, which means they are independent because they can't affect each other. And we want to determine the probability of getting a head and a 3. So we want the probability of a head and a 3 equals, now because they're independent, it'll then be just the probability of head times the probability of a 3. Now a head is going to be a half because when we toss a coin we can get heads or tails, and the probability of getting a 3 on a dice is 1 out of 6. When we multiply the fractions, we will get 1 out of 12. And that's independent events for you.